Another example or opportunity to employ some geometric reasoning about basic shapes would be to ask, what is the sum total of the exterior angles of a polygon? And is there a pattern there that we can establish? So let's just consider the triangle. And what I mean by exterior angle is if I extend a side and make an angle between that extended side and some other side, what is the measure of that angle? And do those three angles there, when I add them together, will they have a predictable relationship or pattern, just like when I added up the three angles on the inside? So let's just take a few facts that we know and reason based on those facts. We know for sure that any line will always add up to 180 degrees. The angle measure of a straight line is 180 degrees. And I also know that the three angles here on the inside of the triangle will add to 180 degrees. So I've got 3 times 180 degrees for these 3 line segments here. But then I'm going to subtract off 180 degrees one time because part of those line segments involved angles on the inside, which I know add to 180 degrees. That would be the same as just doing 2 times 180 degrees. So for a triangle, the exterior angles add to 360 degrees. So we're going to take that same strategy and we're going to apply it to the square. And the square might be easier because we have nothing but right angles here. So we extend the line, and then between the line we extend it on the side is the angle, and create exterior angles all the way around here. And we're fortunate here, this is real obvious. 90 and 90 and 90 and 90 is equal to 360 degrees. We could employ the same strategy as on the triangle, but because these 4 are right angles, it's almost too simple to bother doing that. But we do have 180 degrees for each of these lines, so that's 180 degrees times 4 minus the 360 degrees that we know are total in the inside, and we'll have 360 degrees for the sum total of these exterior angles. So interesting, we got 360 twice with both the triangle and the square, but maybe the square is not very interesting because of those right angles. So let's try a pentagon where it puts us again in the place where we're actually going to have to really use our strategy. So again, exterior angles, extend a side and make an angle between the side and the extended side. And extend the side, make an angle, extend the side, make an angle, extend the side, make an angle. So what are those 5 angles going to add up to? Well, again, we know that any given line segment, straight line, has an angle measure of 180 degrees. So we have the angle 180 degrees 5 times. 180 degrees times 5. But we need to subtract off all of this interior angle stuff here because we're only counting the exterior angles. And what we learned in the previous video was that the interior angles of a pentagon will add up to 540 degrees. So we will subtract off 540 degrees, and 180 times 5 minus 540, interesting, is also 360 degrees. So at this point, you should probably start thinking that, wow, it doesn't matter what shape I use, the external angles of a polygon are always going to add to 360 degrees. And if you're thinking that at this point, you are correct. We will do one more example here. Find the exterior angles, which are these here. And then how many straight lines do we have that are each worth 180 degrees? 6. So we do 6 times 180, and then we subtract off the interior angles because we don't want to count those. But what do we know about the measure of the interior angles of a hexagon? It is 720 degrees. So 6 times 180 minus 720. 6 times 180 minus 720 is again 360 degrees. So at this point, we would be pretty safe to assume that the exterior angles of a polygon will always add to 360 degrees. Now, why this is the case is maybe a more interesting question for another video.